Today I decided to start with a little quote instead of a joke. I read this and I felt like this could not be more appropriate timing. If people do not believe mathematics is simple, it's only because they do not realize how complicated life is. John Lewis von Neumann. Boy, do I feel that way more than ever right now. All right, in this set of notes, we are going to be looking at Module 11. This is Notes W, and we're looking at logarithmic functions. Now, within this section, we're going to make sure that we first define what a logarithmic function is. Then we're going to go back to what we learned about exponential functions, and we're going to learn how to convert between exponential and logarithmic functions. We're going to graph logarithmic functions, and then we'll have a couple application problems that we look at as well. Now, we have exponential functions on this particular slide, and it says to solve each of the following. What we're going to discover here is that logarithmic and exponential functions are actually pretty similar to each other. In fact, they're basically the same. So going back and looking at these exponential functions, and keep in mind they're exponential functions because my variable is in my exponent, we want to solve 8 to the x equals 64. So we're asking ourselves 8 to what exponent would be 64? Well, my exponent here would have to be an x value of 2. 8 squared is 64. Okay. What about 5 to the x equals 125? What would my x value be? Yeah, exactly. It would be x to the third, x cubed. So 5 cubed equals 125. Now, the next one should be a quick, easy one if you think about it. 12 to the what equals 1? Anything to the 0 equals 1, so x equals 0. Now, this next one we got to give a little more thought to. I'm just as guilty as you are probably as reading that decimal as 0.01. But if I read it in my proper snooty mathematical language, it would really be 1/100th. So it's in the hundredths place. So we might be tempted to rewrite this as 10 to the x equals 1 over 100. This is going to make it a little bit easier for us. We know that 10 squared is 100. So if I need that reciprocal, this is going to be 10 to the negative 2 equals 1 over 100. So that x value in this case is going to be a negative 2. All right, last one here. We've got 9 to the x equals 27. This one's going to take a little thought as well. Okay, we know 9 to the 0 is 1, 9 to the first is 9, 9 squared is 81. So we're not going to have an integer exponent here. We're actually going to have a fractional exponent here. So let's kind of think this one through and give it some thought. The square root of 9 is 3. And 3 cubed is 27. The way that we're going to write that as a fractional exponent is 9 to the 3 halves equals 27. So when you have a fractional exponent like that, your numerator tells you your power, and your denominator tells you your root. So this means that we're going to take the square root of 9 and then we're going to cube it. So the square root of 9 would be 3, and 3 cubed is 27. So that's a little quick side lesson on fractional exponents if that's not fresh in your brain. So the answer here to solve this equation would be that x equals 3 halves. All right, so now that we've solved some exponential equations, we need to talk about, well, what's a logarithmic function? A logarithm is really an exponent in disguise. So anytime we talk about logarithmic functions, we're really talking about an exponential function. It's kind of like synonyms. Two things that mean the same thing. We're going to write these in two different formats, but the thought process that's going to go on behind the scenes is going to be the same. So I want to find log base 8 of 64. What this really means is 8 to what exponent equals 64? Well, we just solved that in the previous slide. 8 squared is 64. So that means log base 8 of 64 equals 2. Let's talk real quick about how I just read that as well. We say the word log, and then the 8 that's in that subscript, we call the base. So we say log base 8, and then that 64 is what's called the argument, and we say of 64. So log base 8 of 64. That's how we read it. But again, that thought process is 8 to what exponent is equal to 64. Okay, so if we check out the next one, we have log base 5 of 125. That means 5 to what exponent is 125? Well, that is 3. Log base 12 of 1. 12 to what exponent is 1? That's going to equal 0. Log base 10 of 100th. 10 to the what equals 100th? That is -2. Log base 9 of 27, we're really thinking 9 to the what is 27. That's going to equal 3/2. So these exponential and logarithmic functions, although they're written differently, same thought process is happening behind the scenes. So really logarithms are just exponentials in disguise.